Well, thank you. I was saying for this invitation. It is a pleasure to share with our brothers from Peru and Latin America. So, what we do from CONAE, my name is Josefina Perez. Julia has already introduced me. And so I am working on SAOCOM mission, and I this is in order to tell you what this is about. A process. The SAOCOM process is a big, ambitious mission, and since it is big and ambitious, the development the talk about the development, it will be from what we do from CONAE. So this talk is in that regard. So it's a bit, CONAE is the National Commission of Space Activities, the space agency in Argentina. Here we have the main areas of what CONAE does. It is a comprehensive, yes, description from the access to the space for those in development, and we have already obtained some results. Others are in a process to reach the Troner 2 to put some charges of up to 1,000 kilos in the space to build, in other words, to design, to build, and to operate satellites through SAOCOM. So I won't stop here in this area. The observation of the space from Earth stations. In other words, we at CONAE, we don't only have two Earth stations, one in Cordoba and the other one in Tierra del Fuego in Argentina, where we, of course, operate our services, but we also provide international services to many international space missions that use our control centers in Cordoba and Tierra del Fuego. A fundamental part of any satellite service in the processing and use of satellite information. So all of this thanks to SATCOM and also the operation, because when we think about satellites, we think it's only the satellites, but there is a lot of engineering in all of this mission to operate that satellite, to obtain products, calibrated products from those satellites. So all of this is what we do at CONAE, and now I will go deeply into the Southcom, but also to share that in Argentina we have the National Space Plan. CONAE, the mission of CONAE is to execute the National Space Plan of Argentina. And of course, there are many objectives here, and I'm only listing some of them, and what I will focus on in my talk. So, to go to space from the Earth, so in other words, to have satellites and information, Earth information from the satellite, that is like the main premise in order to offer, yes, strategic information to the society for Argentina and of course for the whole planet. And also, not less important, to use this process, technological process, to mobilize and to produce an ecosystem of the national space system. So with Southcom, we have this challenge. We have started this challenging activity, yes, to provide an opportunity in the national technological development. Why? Because for any satellite mission, when it is more complex, more technological development is required. So at CONAE, and particularly in the management where I work, which is for projects, for the developments, for the yes development, thinking of a space development to build it, to design it, and then to build it. In the process itself, what we do is to open an opportunity to, and we approach the, yes, for public and private partnerships. We visit a university, for example, and we ask them to develop a platform such as La Plata University has done in the province of Buenos Aires, and that knowledge remains. So that is the spirit of the National Space Plan in this technological development. And let me share with you with SAOCOM, we have what we have developed. So in the example of SAOCOM, how all of these missions that we have in our plan, we execute them in Argentina. And so this is the context because Later on, I will go deeply into SAOCOM, and this is very ambitious, as I was telling you. And we could start this adventure because we didn't know how to work on these satellites. Thanks that we have, luckily in Argentina, from the state, this policy that has allowed us to go from less to more. So here, this satellite from CONAE, in terms of Earth observation satellites, we also have telecommunication satellites with a sat company, but at CONAE we have Earth observation satellites, and we started around the year 96. Here we have the scale, the sizes of the satellites, starting with the SAC A and SAC B, then SAC C, and in collaboration with NASA, and then the SAC D, the Aquarius. It has a single instrument, the Aquarius, developed by NASA with an instrument of $50 million, where the platform of the satellite was totally built in Argentina. And that is, as you observe, from less to more, allowed us to develop the local capacities so that we could learn more about the technology and to use that in SAOCOM. So what is about the SAOCOM and the SACs? The SACs were optical satellites. SAOCOM is for the first time that we developed a radar satellite. So yes, my colleague will tell you about the benefits, but all of this information and all is necessary, but they have different characteristics. Maybe the most simple to explain is that it is a radar, which allows us that it has its own power source, and it allows us to take images from any part of the Earth 24 hours, 24/7, and also goes through the clouds, especially for the south of Argentina. It gives us a better visiting of our country and of the whole world, independently if it's cloudy or not. So with SAOCOM, I will tell you so. I should tell you what's coming in the future. In the future, we are developing the Sabia Mar satellite for the monitoring of our oceans. It is a joint effort with Brazil, and the Sabia Mars are already in development, and we also have it's launching by 2023. And we also have other types of technologies, which is the segmented ones. All of these satellites that I'm telling you about, these are satellites very big, yes, very big ones, very reliable. Thought, yes, on its reliability and useful life. The SARE is another technology. It aims to that, starting from many satellites, to allow the functionality of what maybe with a lower quality, but to replace them. So this is the segmented part where we are embarking. Now we are in SAOCOM. SAOCOM, the SAOCOM mission. As I was telling you, this is a radar technology. Its applications I mentioned in here, but you will get a talk by Danilo. But what I would like to highlight is that the SAOCOM has a radar in the L band. In other words, we have the formation of the Earth in the L band that only Japan and Argentina we have this type of technology. So this information, if you don't have a radar, you cannot have this information. So if we from CONAE and Argentina and also from other countries, we are developing specific applications in the L band, which is important to say that still this is a virgin field, a green field, because this is information in the space with these instruments so interesting and so good. So there is a whole area of soil technology for the international artificial intelligence, for the big data, for other applications that we don't know today. So it's important to highlight this because this is an area that may grow, and thanks to the SAOCOM, there is a green field because the development of the applications that is uh, another technology is soil for soil research. Danilo will tell you about this to be ready when we have the data. And not having the real data of the radar was a complexity because we had to develop the applications without the input data, but now we have them and the applications are being developed. So I invite the countries to use SAOCOM to get the fruits of the we maybe things that we don't know yet, new technologies. So now I am more and more going into the SAOCOM mission. What is the SAOCOM mission? This is a mission comprised by two satellites, the SAOCOM 1A and SAOCOM 1B. They have a one single instrument, a radar of synthetic aperture of L band. So this is the SAOCOM 1A. They are identical, 1A, but it could be 1B because they are identical. And from yeah, the back part, this is the face of Southcom, and that will go into the space. The face that you see, the face looking to the Earth. This is a radar antenna of 35 square meters with 7 panels, every panel with antennas. And here we have the thermal layers, is where each of the receivers, and because there are 140, so we have 140 control units, cables. It is huge in technological terms and in terms of electronics that it has. And here we have the central platform. In other words, everything that it does, all of the electronics and the antennas that communicate to the Earth in the altitude, but also the generator of the radar and the memory of the radar so that we may download the products. All of these electronics in this platform was performed by NASA INGAP, and the antenna, all of the electronics that I was telling you about were from different participants, and I will mention that also, the industries that participated. So this SAOCOM is part of a bigger mission. It is a joint mission from the SIASGE, the Italian Argentinian satellite system, yes, for the management of emergencies. And this is even new, brand new. As I was telling you about the L band, and then we have the Japanese bands, but we also have the SIASGE. SIASGE is a satellite constellation for our Italian. The Italian is they also take a radar, means similar technology, but in a different band. So if you want the additional, as you said, they use the X band, but the X band, as you see in this drawing, it has yes a small wavelength. The L band compared, they are if they have 23 centimeters, but compared in comparison they complement each other because the X band is sensitive to a small uh, targets. So it has a good resolution. But for instance, if you want to see a forest, it is so sensitive that it cannot penetrate. But with the L band, maybe they are smaller, but they have a penetration of the forest. Thanks to this constellation, so what we have is 6 satellites, 2 from Argentina, 4 Italians in X band, L bands in the same orbit. So we take images from the same locations with the SAOCOM and with the Cosmo. So we have the X band plus L. So this is very new in the world. So we are accustomed to when we talk about satellites, it takes the whole of the images and the satellite as in itself, but operating this and the whole development of the Earth segment of SAOCOM particularly is huge because these are low orbit satellites, 15 yes, revolutions per day. So from our 2 stations, the one I was telling you, these in Cordoba and Tierra del Fuego, we see them just 10 minutes every time the SAOCOM passes by. So in order to operate it, if you have what SAOCOM is new, is that this is an operational satellite. This is asynchronous. We command what the SAOCOM will be tomorrow as an emergency. So the logistics is very important. So that's why we have stations around the world that provide us support. As I was telling you, we provide support to other agencies and to other missions. Particularly, I can mention that in Lima, a station provided support. It was the first station that saw SAOCOM is launching, because when we launched, it was even more. It was the first view from Lima. Then we have other stations in Italy, in Africa. We have in the two poles also. Yes, the readings of the poles are very important because of the passing of the satellites. And as I was telling you, this is Earth infrastructure, so that the satellites, the two SAOCOMs, are commanded from Cordoba. The command is sent to the satellites. So, and whenever they have scheduled the timing for the taking of an image from Earth, they take it, and then they send the images to the Cordoba Earth station, where the images are processed. As I was telling you, the SAOCOM mission is this image. As you see, this is the catalog, SAOCOM catalog. If you go into the CONAE website, you will fill out a catalog with a small inputs, some data, and you may enter, and then you choose one area of the map. So what the catalog is going to give you is going to show you the products from the SAOCOM 1A, not from 1B yet, because they have not been calibrated yet. So these are managed with users from CONAE. You will be able to download them and to provide the products. And if you have the permits to schedule one acquisition from any part of the world, and that acquisition will be sent via email to the user who ordered it. So here we have an image from Cusco. We have the airport, Cusco Airport, that was taken on August 24th of 2020 by SAOCOM 1A. So what I'm telling you here is that looks that I'm showing you in terms of development, it was very challenging for CONAE, because that implies as everything the click from the user to log in and to trigger an activity of the satellite. Then that satellite captures the image, and that satellite is downloaded, it is sent, it is processed and sent to the user. All of that, yes, is through SAOCOM. So then now we have the radar technology. But at the end of the 90s, it was decided CONAE in the Space Strategic Plan to develop radar satellites for its application, yes, the L band for soil readings, ground readings. So CONAE Argentina decided to embark in this adventure, but we didn't know how the radars operated. So the first thing we did was to travel. I got into CONAE in 2005, but before that we participated in workshops, and we got some training for foreign experts. But something right from CONAE was to design a prototype of the radar that was on a plane with a similar technology of a synthetic technology, and it allowed us as engineers. You see a photo of myself. I was younger, so they allowed us to see this in practice, and also to have the L band to observe the this branch, or first it was the acquisition of data and then the applications. So we had this prototype, and in parallel, so we started yes, the papers and the design of the SAOCOM. Once we knew, once the engineers, how it worked, what we did was to go and build the SAOCOM. And satellite technology, I don't know if you know this, but the standards tell you that if you're going to start a new development, don't go and build from the papers to build the model of the satellite that will fly, because there may be errors. So what you do in the cases of the new and the SAOCOM national design, which is totally new, you develop models, you design the models, where we as engineers, we can play. And yes, from the papers, if we design a satellite that we think that it will work, so we build different models that allow us to confirm or not, because we learn from our mistakes that these models are working well. So with SAOCOM, this is an example. This is a structural model. So mechanically, it is identical to the SAOCOM, but it doesn't work. So here we have the structural model of SAOCOM mounted in Bariloche. So with the vibration tests, where the mechanical engineers consolidated the mechanical design. This was a very complex design of the thermal model, one of the most complete subjects or disciplines for any space technology is the thermal part. Why? Because you cannot simulate that, because on Earth you don't have the variations. Very difficult to simulate the minus 100 degrees that the SAOCOM parts will suffer. So we made a representative representation of the antenna. This phase of the antenna, as I told you before, it suffers. The electronics inside the antenna suffers temperature changes from 100 degrees to minus 100 degrees. So there is no simulation possible for this. So the thermal band allows to guarantee thermal range of the electronics so that they operate. So the thermal model and the thermal control of the antenna should operate, and if we made any mistake, we cannot make a mistake basically. So this was the testing of the solar model that, yes, helped us with the thermal testing of the antenna. And before we built the model, we used the radar in this complexity that we couldn't use its instrument, its radar, as a radar. Why? Because the radar is of a synthetic aperture. I'm not going to go into the theory, but it requires movement. We didn't know that the antenna weighs 1600 kilos. The SAOCOM weighs about 300 kilos. So we could not simulate this. So what we did was an inverse radar testing to confirm this in Bariloche with the engineering model, with some functioning or operationally, but totally different, mechanically different to SAOCOM. So we performed the design. It was around 2015, and then after we completed the testing, and then we went to build the flying model, the SAOCOM that would fly. And as I was telling, now going back to the space, the strategy and the execution in Argentina, and particularly in my area of work, what we did was to open the flight. So with SAOCOM, a difficulty we had at CONAE is that it was communicating to different parts of the country. Here you have Buenos Aires, the Atomic Energy National Commission, the mechanics of the panels were developed of the antenna. It has a requirement, these 35 square meters that you see, of about 6 millimeters. In other words, that no deformation, thermal deformation, or no mechanical deformation, and also its stiffness has to be enough to stand the 600 kilos. So we asked the Atomic Energy Commission, and this became into a material lab and a design of the SAOCOM antenna with the panel, as the panels were being consolidated and all the electronics were coming in Cordoba in this integration that we have at the space in Tabarena of CONAE. They were integrating the antennas, and each of these antennas panels, they were being tested in different subjects, different temperatures, in different electromagnetic testing. And as I told you, this was a new design, so everything was very carefully done and a long process. And here also in the room of the testing interaction in Cordoba, before, this was the most important testing of the antenna for SAOCOM 1A before storing it and taking it to Bariloche. So they were developing this platform, these electronics, with many, many boxes that INVAP developed, especially performed for SAOCOM, and the electronics, the radar, the memory of the radar, and the platform to command the satellite, and for the altitude management and control, everything done from Bariloche. And once the parts were put together, they were taken to Bariloche, to the Argentinian Patagonia, and the integration of the radar antenna, the SAOCOM, has two setups. The setup for the launching, and once it's launched, the satellite, during the night, that huge antenna is deployed to be like that for its whole life. So here we observe the integration of the antenna, the SIAPSA integration. Here, vibration testing of SAOCOM before going to the acoustic testing. One of the characteristics, something that it is done when we put the parts together, is to test it, to put it under the conditions ready. So it's not just the design of the satellite, but also the design of the tests of the if its structure. So in the past in Argentina, we didn't have the capacity to test a satellite of this dimension. And in our country, we used to go to Brazil, but now we are doing it here with SAOCOM. It's 3,000 kilos. One of the most important tests for its design, the acoustic testing, where you simulate the acoustic damage or impact that the satellite will suffer. So you can see here, these are 10 seconds, but very important. And afterwards, once this is completed, we deploy the antenna and we perform the electromagnetic deployment for the deployment of the antenna. Once that is completed, it is deployed. It is sent to, in this case of SAOCOM, with bidding of SAOCOM 1A that was done several years before. The company SpaceX, as I was telling you, a very important satellite due to its dimensions. So in the past we didn't have the launchers, but with the new SAOCOM were launched by the SpaceX company, and the launching campaign, the engineering in itself, if it's true, these 40 days, crucial days, the logistics of moving those 90 parts, those 500 items, and they are sent from Bariloche with the almost the only aircraft. It was a Russian Antonov, Ukrainian actually, that took it. So it was launched in SAO1A in 2000, last launched in October 2018, and SAO1B in August 2020. So last week it reached its orbit. Now it will go to through its calibration to join the SAOCOM mission. So now, yes, following this example, we, as I was telling you, we have first in the first line who participated at SAOCOM, INVAP, a public company, yes, from the state. So we have the National Commission of Atomic Energy that worked on the panels, an institution of from the Ministry of Energy, the University of La Plata, the mechanical research, some private companies such as Sur and Ascentio, with all of the software, Earth software. So all of this to tell you the number of players or stakeholders or the prime contractors. They were many, many participants, and in the amount of people, 900 scientists in the country worked in SAOCOM, and an infinite, well, but many, many disciplines. This is what is interesting about these projects, that they have engineering, but also agricultural people. Without the agricultural people, we didn't have it started. So we did all of this so that they could use it for the agriculture productivity. It's one of the applications. And then physics, mathematics for the orbit, and the software, many, many disciplines or subject areas working jointly with their knowledge in Argentina, particularly because it's our country. But here there is an example, and I keep saying it. What is this leaving us? It is leaving us the capacity to build, not only to build, but also to design, build, testing, and operating radar satellites, which is not minor, because this is very sophisticated information that we will obtain from the radar. And here, as you have heard, one image is worth 1,000 words, and a radar image is worth thousands of words, many, many. It's very complex. That's why it's very powerful information. And in Argentina, we have these two satellites, and of course, we are using and capturing in all of the Argentina again and again, but it has information of the whole planet, and particularly I invite our Peruvian friends to use them and if you already use them, and also in the training. I consider in this to go through this process with this type, it allows training the human resources that may be challenged more and more with those basic or fundamental knowledge, and to go to bigger projects as we have observed in Argentina. Infrastructure, the lab, as I was telling you, we didn't have it before. Well, we had one, but it was a smaller one. SAOCOM required expanding it, and it's also good for other industries such as the automotive industry, and also the stations. The one of the stations was inaugurated with SAOCOM and the capacity on radars. So now let me show you a slide, because this is requires a specific satellite. I mean a slide, but all of this is in development. The mission, which is the main driver, but everything else, yes, gives us this process of development. And as I was saying, national development. These are the solar panels that the atomic energy helped us with. Yes, so in this space race has allowed us to produce this technology, and now any satellite may yes, export and have make use of these solar panels. And another good examples, if you want, of maybe byproducts or secondary products. I was saying that in Argentina, we didn't know about radars, so it was decided to have this project. We had to learn, we had to develop. For the main company, INVAP didn't know about radars either. So CONAE approached them and told them we're going to build a satellite this type. So there was this opportunity, a decision from the government to get radars into the country. So these are all the radars that have been developed since 2003 in Argentina, thanks to that we launched, that we started, yes, with SAOCOM. We say this was like our spin-off of radars. So maybe it was not the main target of SAOCOM to have this type of consequences, but that's what it brought. And just to close, a beautiful image of the peninsula of Paracas in Peru. You can see here the small boats, just for an introduction to Danilo, and he will show you the applications, and well, and open to your questions.